JUnit introduction. So if you have used JUnit, I assume most of you do, this might be a little bit of basic. So here we're going to talk about what is JUnit, and we're going to learn some of the important JUnit annotations, especially test and before, and after and before class and after class. And we'll talk about assert statements, and we are also going to talk about more recommended the assert scheme, which is called the assert that, which is actually giving you more English-like way of actually asserting. And we'll talk about testing tools, especially infinite test and code coverage tools. We are going to use Echo Emma in this code camp. We'll see how we can handle exception handling in JUnit, and we are going to also learn parameterization of test data. And we'll also learn some of the best practices. What is JUnit? It's a unit testing framework for Java, and it is a de facto standard for JUnit unit testing for Java community, and it is free and open sourced. So annotations that we are going to use, the first, test is probably the most frequently used annotation. You're going to use that annotation for each test method. Well, if you specify at the class level, then it gets applied to every single method of the test class. Before and before class and after class, and ignore. So let's take a look at each of this. How to write the test unit. JUnit test, basically you're going to write the test class with a test method, and each test method has test annotation. And the method signature of each test method should be public, and it should not return anything. So it should be void, and it should not have any arguments. The way you can actually set things up is by using before and after. So before gets called before each test method, and after gets called after each test method. If you want to actually call a particular method, before all tests are run, then you can use a before class, and after class is again just one shot deal. So basically after class method will be invoked after all tests are invoked. Ignore annotation is used to temporarily ignore the testing. So this is an example test class. So we have a calculator test class, and it's going to test calculator target class. So we have a before annotation, which we set things up. Typically, you can create a target object. In this case, we create a test, the target calculator object, and then we are going to have test method. So should return addition when two numbers are given, should return subtraction when two numbers are given. And here we use assert statement. One is using assert equals, the other one is using assert that. So in this code camp, you're going to actually use mostly assert that because that's more convenient and more readable. And we're going to actually talk about those things in a bit more detail in the latter part of this presentation. Okay, so let's talk about assert statements. So JUnit assertions are methods start with assert, and it basically is used to determine the success or failure of a test. And the assert is simply a comparison between expected value and actual value. And you can actually use two different variants of assert statement. One is without failure message, and the other one is with a failure message. So assert XXX, and if you specify a message as a first argument, this message will be displayed when this assert fails. So these are examples of assert statement. Assert equals, assert same, assert true, and assert false. And you also have assert null and assert not null, and we can also have a fail method, which you can force a failure. So instead of actually using assert statement, the recommended of doing assert is using Hamcrest assert that. So let's talk about what Hamcrest is. Hamcrest is a framework for writing matcher objects, allowing match rules to be defined declaratively. And these matchers are now part of the JUnit. And JUnit 4.4 introduced a new assert that using this core matchers and JUnit matchers, the class. And basically, you're going to use assert that, and then you provide value and matcher statement. So let's see an example of those. So in this case, assert that driver age is 18. By the way, is deprecated. Instead, you want to use equal to whenever possible. Okay. So basically, as you can see, assert that is more English-like statement. Assert that driver age equal to 18. Assert that driver age is not 17. Assert that driver name contains string sanction or is sanction or equal to sanction. Assert the first name of the driver either contains string of moon or contains string ABC. So it does have either and or options as well. So this is, again, much more English-like language than assert statement that we just have seen. So why Hamcrest? So this is what I just talked about. It's more readable and typable. The syntax allows you to think in terms of subject, verb, and object. That's again more English-like. Assert x is 3 rather than assert equals, which uses the verb, object, and subject, which is kind of not natural. So equals 3x. So that doesn't sound like in English, right? Okay. And again, you can see you can have combinations. Any matcher statement can be negated. So you can use not. Any matcher statement can be combined, either or. By the way, when you're using Eclipse or STS, you might want to actually add this static classes into your favorite. So basically, let me just demonstrate that. So you go to Preferences and go to Java and go to Editor and Code Assistant. If you expand it, there is a favorite. So if you want to add these static classes, org.hamcrest core matchers. So basically the way you can add is basically type, click new type, and then you can just type org and Hamcrest core matchers, and then click, then you can actually add these static classes. So this will help you later on when you actually import static classes by using the Control-Shift-O. Okay. All right. So this is what I just demonstrated. So go to Java, Editor, expand Content Assist, and select Favorites, and try to add these static classes. Okay, so we're going to do our first exercise. So assuming that you can download the hands-on lab zip file, so click this guy, and you should be able to download. You can save the file into a location in your file system. So in my case, I have already have it in these job files, and you're going to just unzip the job file, zip file. So I'm going to use the jar command, jar xvf and JUnit zip. Okay, and basically you're going to actually import the classes, projects, import and existing Maven project, and go to labs. In my case, go to labs, and here JUnit, and I provided solutions. Okay, so I'm going to actually import all. For you, you can just select the sample Maven, and you are going to actually work on 2 projects. So we're going to actually start with the calculator thing first. Okay, so I'm going to just import even solutions so that I can just compare some of those later on. Okay, so when you actually see calculator JUnit start, take a look at readme.txt file. So that is your lab. So I'm going to actually do exercise 1. I'm going to actually demonstrate this, and then you're going to actually do the same thing as a lab exercise. So here what we're going to do is we're going to create a calculator class that contains a very simple add method, which takes the int x and y and return int as a result. And you're going to write the JUnit testing code that tests the add logic. So here, if you take a look at the directory structure. We have src main Java and src test Java, and this is a Maven project. So if you take a look at the pom.xml file, and basically we have a very simple dependencies, JUnit, and we're going to use the Hamcrest. Okay, so we're going to actually write the test code first, following the TDD pattern. So here we're going to write the new test class. So new class, and we're going to call it calculator test. Okay, so now we're going to actually add test methods. So I'm going to actually use test. So it has test annotation, and in my case I actually have a template that starts with a should. So should return added value when two numbers int are given. You want to actually write your testing code more like English-like language. So in this case, should return added value when two ints are given. So here, first I have to create a calculator target object. So here, calculator is going to be calculator, and the new calculator object. And of course we have this calculator class that is not created yet, so we're going to create calculator class. Okay, and we're going to create in src main Java. So finish. Okay, so we have a calculator class. Then we are going to, usually I want to actually do is I have this testing code and calculator target class on the right. Okay, and let me actually just expand it. So here, yeah, let me just expand it this way. So here we're gonna write the testing code. So here we're gonna say calculator actually it should actually, oh, we should actually select this guy, calculator, and call a method. So I'm going to say add, and this is going to, you know, add some number like a 2.2, and it should be 4. So I'm going to use assert that, assert that, and this is the actual, and expected value is or equal to. So I'm going to use is first. Okay, and let's actually have to add this, the is static method here. Core method is, as you can see, is deprecated. Okay, so you can actually use equal to if you want to. So we're going to actually try equal to later on. Now, since we have not added we don't have any add method in our target class, so we're going to actually create the add method. So create method add int right here. Okay, and here we are going to actually return int, and this is going to be x, and this is going to be y. Okay, and TDD, you want to actually provide the simplest possible solution. So we can just, for now, just return 4. Okay, and see whether that works. Okay, and let's actually save the change. Okay, and you can see I have infinite test, basically letting me know that this is in fact the succeeded. Now let's see what this is all about. Sometimes infinite test method add int is undefined in calculator. Yeah, so that's not really true here. So we have in fact the added. So let's, in this case, we'll just try to run the test. Oops. We can actually run the test. Says the error. So we have int And oh, so I don't know. Oh, okay. So I actually didn't actually. I just Control Z too many times. Okay, good. So now you should actually gonna save the change, and you can see test is actually successful. And I can certainly run the test and run as and a JUnit test. Okay, and it actually has been successful. Okay, so that is your first exercise. Write calculator class that has int add method and write JUnit testing code that tests the add logic. Okay, all right, so let me just make sure. Yeah, one thing I have not demonstrated in this case is that, you know, if you try the 2.3, and obviously it's not going to work, right? So let's actually try that as well. So I'm going to just add another statement. This time we are going to try to add 2 and 3, okay? And if I save the change, it will fail. Okay, no, it didn't fail. Oh, it returns 4, right? Yeah, it should be 5. So I have to actually provide the correct number, and now it fails. So if I run this code, you know, it will tell that expected value is 5, but it returns 4. So this is a time that you need to refactor your code. So here, instead of 4, we're going to actually return x plus y. And again, save the change, and then you can see the test succeed. Okay, all right. So actually that is the end of the exercise 1. So you can actually try this one as well. And you might want to actually try a couple of more tests if you want to. Okay. Okay, the next part of the presentation is tools. So we like to have at least automatic testing tools so that it will help us speed things up in our development. So each time a change is made in the source code, whether that is in the testing code or target code, test should be run automatically. Right? And that is Infinite Test plugin that we are actually using in Eclipse. And we're going to actually see how we can use a code coverage tool. So there are a few code coverage tools out there. We're going to use ECLEMMA, and you can also use what is called the Jacoco. Okay? So it is used to describe the degree to which source code of a program is executed when a particular test suite runs. Okay? And we are also going to use a JIT as a version control later on when we are doing a reasonably complex the refactoring. You know, we like to keep track of the changes we made, right? So you want to use some version control system of your choice. In this lab, we're going to use JIT. And we're not going to actually use a continuous build tool here, but in general, in the production environment, you know, you should actually use continuous build tools such as Jenkins, the continuous integration tool, I should have said, Jenkins to actually see you know, whatever somebody checked in a change, the build should be redone to make sure that things are still working. Okay. Okay, so exercise 2 is installation of tools. So Infinite Test, I don't think is available in the marketplace. So let me actually demonstrate the ECLEMMA installation first. Go to Help and go to Eclipse Marketplace. And then if you say ECLEMMA, okay, then search. Oh, so maybe you should actually said code coverage. Code coverage, and then ECLEMMA should be actually one of the ECLEMMA. What is the ECLEMMA? Code coverage. Yeah, so interesting. Emma, what if I type Emma? So I'm going to demonstrate the ECLEMMA in a few seconds. And so once you find the ECLEMMA, then you should be able to just install it and restart the Eclipse, and you're all set to go. Oh, here you go. So ECL, so you can just type ECLEMMA, and in my case already installed. So basically, once you have ECLEMMA, what you can do is you can right click it, and then you're going to say code coverage, and then in this case, since you're writing testing code, you select the JUnit, and it actually gives you a sense of which code of the target and which code of the test code has been covered. So we have 100% code coverage because we have a very simple code. Now infinite test, as you can see, whenever we make a change, it's actually testing it again. So here I'm going to actually use, instead of is, I'm going to use equal to, and save the change. Again, I have to actually import this class, okay, and save the change, and then it will rerun the test, and it will give me an indication in the left lower corner of the ID right away. Okay, so just for the sake of this exercise, I'm going to change it back to like a 6, which is not correct. And if I save the change, and it will give me an error. Okay, and you can actually see the actual error right here. Assert error, assertion error. Expected 6, but was 4. Okay, or at this point you can actually run the test, and you're going to actually see the same results. Run as and JUnit test. Okay, and then you can actually see the JUnit right here, and it will give the same result. But as I said, usage of the infinite test is actually a lot easier to actually see what's going on. It's really speed things up. So let me just change it back, and then again save the change, and then it rerun the test and give me indication. So this is pretty cool. All right, so the infinite test I don't think you find in the marketplace, so you have to actually Google it, and so if you do Google infinite test and go to infinite test, and here this is the update site. Okay, and they said you can also drag and drop this image into running Eclipse. So you can just drag and over here, that kind of give you actually let you actually install the plugin, or you can actually get this update site, and then basically you go to help and install new software, and then you can actually provide like this, and then you can actually select infinite test for Eclipse, and then you can install. Okay, all right, so I'm gonna let you guys install infinite test and Emma. I'll give you about 5 minutes. Yeah, so you can actually get the infinite test plugin from the marketplace as well. Okay, that's good. Next topic is exception handling. So there are 3 different ways that you can handle exceptions in JUnit. The first is using @test with the expected and attribute with the exception class, and the other one is using rule, which is a bit more powerful than test, and then try-catch idiom. So let's talk about each of these in a bit more detail. By the way, try-catch idiom is actually an old way of doing things, like a JUnit 3, so this is typically not used. So we're going to actually focus on the first 2. So test expected exception class is supported in JUnit 4, and basically what you do is that you're going to specify expected equal, and then you specify the class object of expected exception. Okay, so in this case we're going to actually try to throw an exception when negative number is given. Okay, so here well, actually this is not even right, so actually it should provide just the 2 numbers instead of 3. It should actually return the illegal argument exception or runtime exception, and that's what is expected here. Okay, so if this add method in fact throw this exception, then test succeed. If it doesn't throw that exception, then the test is going to be failing. It's going to fail. The other one is a rule. It is again supported in JUnit 4. This is actually try to be more powerful. For example, you can actually check the expected message. So first thing you have to do is you're going to use the rule annotation with the public method and public the attribute and expected exception, and then you can give the variable thrown or expected exception. And then here you're going to actually call none method of expected exception. So at this point there is no expected exception. And then in your testing code you can actually call expect method. Now I'm actually expecting illegal argument exception object, and also I can specify what is the expected message. So here I can check whether it is in fact the well, actually, this is not really correct. So I should actually provide just a string. Okay. All right. So let's actually try that in the lab. And try catch is kind of old way of doing things, and it is still being supported in JUnit 4. So the structure is something like this. You can actually call the fail method here, and then you also do catch here. So if there is in fact the exception, then it will catch, and then you're going to actually use the assert statement here. Okay. If the add does not throw an exception, then it will call this fail. So that's going to actually fail your test. Okay, so this is a bit more complex than the other two schemes, the rule and test. So again, this is try catch is rarely used. Okay, all right. So we're not going to actually use the try and catch. Instead, we're going to actually try the test with the expected and also rule case. Okay, so that's exercise 3. So if you take a look at the exercise 3 here, when negative number is given, throw runtime exception with a message of negative numbers are not allowed, and then you specify, whatever number that is negative. So you can just display the first one. We're going to try both test and rule schemes. Okay, so let's actually try that. So here we're going to actually try write code in the test code first here. So test. So should throw. We're going to just try to a runtime exception. Runtime exception when negative number is given. Okay. Okay, so here we're going to actually use, should throw runtime exception when negative number is given. Okay, so here we're going to actually again create the target object calculator, and I'm going to just copy this guy, and of course we're going to actually refactor so that we can actually do this just once, but I'm going to actually just show you these things first. So here I'm going to just copy this down here, okay, and I'm going to just delete Control D, okay, and here we're going to use the calculator, and we're going to call add, and this time you're going to use -2 and maybe 4, something like that. Okay, so this one should throw an exception. Okay, so we're going to use test expected and runtime exception plus like this. Okay, and let's see whether it works. It should fail because we haven't actually, tried to throw an exception in our target code. Okay, so it failed, right? So here we are going to actually now refactor our code to satisfy this testing method. So here what you're going to do is if x is less than 0 or y is less than 0, then we are going to throw runtime exception with some message. Okay. Throw new runtime exception. Let's see what doesn't like it. Oh, runtime error exception, so I should say runtime exception. Okay, so we want to try runtime exception. Okay, and then we save the change. Okay, and our test succeeded. Okay, all right, so now we want to make sure, so this case, we do not check this sum message, right? But what we want to do is, if you take a look at the requirement, it should actually say something like this. negative numbers are not allowed or something like that, and then it should actually display 34. Okay, so we're gonna actually copy this guy. Well, actually, let's try actually, write the code first. Okay, so we're gonna actually write the code test. Okay, so throw runtime exception, and when well, in this case I would say runtime exception with message. Okay, just for the demonstration. Again, so one thing that we have not refactored in our case is that now we have duplication of the code here, right? So we are creating calculator, and we're also creating calculator here as well. So here we're going to actually refactor. So we'll say before the public void, and it's going to be setup method. And here we're going to actually create calculator object. So you're going to actually move this code right here. Okay. And we want to refactor so that it goes to actually, yeah, let's see. I want to actually create the a field from this guy. So click this guy and refactor and convert local variable to field. Okay, so I'm actually trying to demonstrate the usage of Eclipse as much as possible. You can just kind of do these things yourself, right? Okay, so now let's actually import the before. Okay, so now create the calculator object for each test. So we don't need this one anymore. Okay, and whenever you make a change, make sure you save the change and make sure testing still succeed. Okay, so this is the idea. Whenever you make a small change, run the test. Again, infinite test will help you out. Okay, so now we're going to try to see whether we can even test the message as well. So here we're going to actually use the rule. Okay, so here specify rule. Okay, and it has to be public. Okay, and then expected exception, and you just give whatever name of your choice, expected exception, and here we're going to actually call, expected exception call. Yeah, so let's actually import the class expected exception. Oh, this is not right. Expect exception, and then yeah, so you choose none. Okay, so for now there is nothing expected. Okay, now here we are going to we are going to actually expect something. So we're going to actually expected exception and expect. Now we are expecting runtime exception. So runtime exception class object. So we expect a runtime exception object will be thrown, and then here we're going to actually check the expected message as well. So expected exception, and here expect. You can see that it's in fact expect message. Okay, so expect message, and here we expect the message that is specified in here. So negative numbers are not allowed. So we're going to try 34. So here, so this is a message that I expect. Okay, and then we are going to actually call the calculator method. Okay, so here I'm going to actually copy this guy and move. Okay, all right, so let's save the change and see whether it fails. It should fail because it doesn't actually give the correct message. Okay, so in this case, infinite test doesn't give you any detailed information. So in this case, you can certainly try to run the test and see what is in fact the failure. So here you can see expected should return this message: negative numbers not allowed 34, but it actually give the negative numbers not allowed 34 was yes, but it returns 30 some message. Okay, so if you take a look at the message here, the message is not correct, right? So we need to, we're gonna just, for now, we're gonna just copy this guy to see whether that works. Okay, we're gonna actually copy the same thing here. So again, in TDD, you wanna actually make as small list possible changes as possible. Okay, so I'm gonna actually hard code this value and save the change and see if it works. So you can see infinite test, that works, right? Okay, and obviously this is not something that we want to display. Okay, so here in this case, infinite test should, in this case, it should be -2, right? So here we're gonna actually give the correct value, because that is the negative value that we actually passed. Okay, so save the change, then it should fail. Okay, the failure is, again, it should actually say this guy, but it does display 34. Okay, so obviously that is not right. So this time we're going to actually refactor our target code. So it should actually return either X or Y. So in this case, we know it's an X, right? So we can just display X. So here. Okay, and let's save the change and see if it works. So now it works, right? And now we want to actually check whether the Y case is in fact also causing a problem. So in this case, we're going to try calculator. So again, I'm going to just copy this code. And here, instead of, here we are going to say and -4. Okay, and this will fail, right? Okay. Oh, okay. So in this case, so this is probably so this is not right. So here, what we want to do is so in this case, we don't actually have this method in the same code. So as a simple solution, if you want to try the second one is in fact the minus, then we're going to actually try another method. Okay. Again, in TDD, you want to actually find the simplest possible way of actually moving forward. So in this case, with a message with when message and when X is negative, and this one is when Y is negative. Okay, so in this case, I should actually return this value. In this case, we are going to try 2 and -4. So it should actually display -4, something like that. Okay, and if I try this guy, and again, it should fail on this guy, because in our target code, we are basically sending X, right? So we have to actually make sure in this case, we're going to actually display only the negative value. But actually, if you take a look at the README file, maybe actually I'm doing more than what is being said. Okay, actually I meant to actually say just display the values, like a 34 and 5, something like that. Okay, so that was actually my original intention, but I think the requirement is a little bit vague. So this is another practice. When the requirement is vague, this is an opportunity. This is an opportunity that you actually talk to your customer, to clarify the requirement. So in this case, does it actually say, does it actually want to display both numbers like this, or it does display just the negative number? And if that actually both of them are in fact negative number, do you want to actually display both? Okay, so these are the things that you need some clarification from your stakeholders, okay, in real life. Okay, so for now, so we're gonna just continue with the, we'll just display in this case just the, so we can certainly have a logic here. So again, the simplest way of doing things is, we'll just do this, and if X is less than 0, then we're gonna just say this. And also we're going to have another one, like if Y is less than 0, in this case, we are going to throw Y like this. Okay, and let's see if that works. Okay, so that works. Okay. All right, so I think that's actually good enough for this exercise. I don't want to spend too much time on this guy. Okay, so I'm gonna actually give you guys about the 5 to 10 minutes to finish exercise 3. So I can click this guy, and then there is a folding. So if I collapse all, basically what I have is this statement: should return added value when 2 ints are given. Should throw runtime exception when negative number is given. Should throw runtime exception with message x is negative, and should throw a runtime exception with message when y is negative. So it kind of gives you a sense of what you are in fact testing. It's more English like BDD style, right? Okay, so that's the reason I actually start with a should, and I actually modify the template, okay, to kind of follow that pattern. Okay, the last topic of JUnit presentation is parameterization of the test data. So parameterized test is used when we find ourselves writing identical tests where only the test data are different, okay? But the logic is the same. So, in this case, we want to actually write a single test method, and then we want to feed different test data using what is called the parameterization. So let's see how we can do that. So this is the code. So in our case, basically what we need to do is, first of all, you're going to actually annotate your class with the run with parameterized.class object. And then what you have to do is you provide this parameterized test data. So in this case, it's going to be it's basically x and y and result, x and y and result, and x and y result. So we have 3 test cases, okay? And then you have to have a constructor method of your test class. So in this case, calculator test constructor class is receiving x and y and 3 arguments. The first 2 are considered as the arguments, and last one is considered as a result. So depending on your testing code, depending on the method you're actually testing it, the arguments could be actually different. Okay. So here you also have to have a private fields of x and y and result for the argument you specify, and you're basically setting these private fields with this. So what happens is that underneath the parameterizer scheme of JUnit is going to take the first data here, and then it's going to feed as a constructor argument for creating your calculator test object. So there will be in fact a multiple calculator test object with a different data set. So that is how things work. Okay. All right. So you're gonna actually do exercise 4. So exercise 4. Let me actually finish up the JUnit best practices first, and then we're gonna actually do exercise 4. Test code versus production code. Your test code becomes part of your code base, and you should actually check in as part of your source code. And in a test code needs to be documented, although not as heavily as a production code. And note that test code will mostly likely not deploy with a production code. I mean, that's certainly the case. Okay? You want to be as thorough as possible, so you want to achieve 100% code coverage whenever possible, except the cases where tests are just too simple. Examples of too simple tests are like a getter and setter method. Okay, so those are considered as the too simple to fail, so you don't actually add those tests. Write multiple tests for each method: positive testing and negative testing. So negative testing is basically exception case. Okay, and you also want to try the boundary value testing. Okay, so in our case, we might want to actually test it like a 0. That is kind of boundary between positive and negative value, right? So we want to actually see whether 0 is in fact being handled correctly. Okay. All right, so let's actually do exercise 4, which is a parameterization. So what we want to do is, let's just move this guy. So this is the, what we want to do is, we want to actually provide the multiple data set. Okay. So first thing you want to do is, so you're going to actually use run with, and then parameterize class. Okay. So we're going to actually run with parameterized class. And then in this case, we need 3 arguments, x and y and, basically result. Okay. So we need to have a private fields. So it's going to be private int x, private int y, private int result. Okay, instead of result, yeah, how about edit value or something like that to be more descriptive. Okay, and these private fields will be fed by constructor arguments. So we need to create constructor method. So again, here I'm going to use the Eclipse help. So Alt Shift S is going to give me the source, or you can just right click it and select source here. And here we're going to create the constructor method from fields. Generate constructor using fields. And here basically what we need is these 3 fields to be used as a constructor. Okay, so we have constructor. So let's actually move this guy below this guy. Okay, and just move the line here like this. Control D is deleting a line. Okay, so we have private field. I'm sorry, the constructor that is actually receiving these 3 arguments. Okay, now we have to actually create the parameterized value. Okay, so in my case, this is another example that I want to the parameters. Actually, I created yeah, here you go. Okay, so this is another example that you want, in fact, the create a code template. Okay, because this is going to be exactly the same. Okay. Okay, just so here, this code. Let me actually import the classes. Okay, this code is exactly the same. Okay, the only thing that is going to be different is actual test data. Okay, so parameters. Public static collection, test values, return arrays.addList, a new object, 2-dimensional array, and the test data in this case is going to be 2 and 3, and should return 5. And the other one is maybe 10, 20, returns 30. And here 6 and 7 should 13. Okay. So let's see whether things work. So I'm going to just save the change, and it worked. Okay, and for the sake of an exercise, I'm going to actually just say 130, and it should fail. Okay, sometimes failure actually takes a little bit of time. That is not right. So something didn't work. So in this case, let me actually just run the test. Okay, so test succeed. So that's not good. So things didn't work. It should be 13, right? So we have a run with parameterized class. Let's actually, I'm gonna actually try the solutions and see whether that actually fails. Control. So here, final. Here. This is the test code. That's exactly what I have here. Right, and let's see whether this one, and I'm going to just change it back. This one is 100. Save the change. Oh, okay, now it failed. Oh, maybe I didn't save the change. Okay, so let me just make sure this one really fails. Yeah, so it definitely fails. So that's our solution. So so the solution definitely behaving as expected. Okay, so I change it back, and then it succeeded again. If I run the test again, then it succeeded. Okay, good. So what is the difference between my test code? So this is a solution. So here, run with parameterized parameters, and we have oh, did I actually do these things? Yeah, I didn't do this part, I guess. All right, so that's the reason. So I did. Calculated test. Let me just make sure I'm actually using the right code. Oh yeah, so this is my testing code. So result and parameters and yeah, so this is my testing code. Okay, so let me just close this guy, and this is the one that I want to actually test. So this one, let's see whether save the change. Okay, it still succeeds. So what is going on here? So we did run with parameterized class, and we have x, y, and added value, and we create a constructor. I'm going to just remove this guy, save the change, and parameters, collection test values, and so this one, oh, what is this? Okay. Oh, you know what? Yeah, so our testing code is actually the not using x and y, right? So yeah, this is the problem. So, you know, basically we are using hard-coded value, right? So we have to actually use x and y, and that should be, in this case, added value. Copy, added value, and then we don't need this hard-coded testing anymore, okay? So now if I save the change, it should fail, okay? So now, you know, I should actually use correct value and then save the change. Now it should succeed, yeah. So I didn't actually finish up the refactoring of the testing code so that it actually uses the actual variables, okay? All right, so I'm gonna give you guys about the 10 minutes, try to parameterization, okay?